Something is deeply wrong with the moon. Not the moon you know, not the one you've been looking at your whole life. The other one, the one nobody ever sees. When China's probe sent back the first close-up images from the far side, scientists went quiet. Not because it was beautiful, because it shouldn't look like that. The math didn't work. The geology broke the rules, and the explanation, when they finally found it, pointed back to something that happened 4.5 billion years ago, something so violent, so extreme, that it literally cooked half a world and left the other half to freeze in the dark. I'm going to show you exactly what they found and why it changes everything we think we know about the moon, but I'm saving the most disturbing part for the very end, because once you hear it, you will never look up at the night sky the same way again. Quick question before we dive in. Where in the world are you watching this right now? Drop it in the comments. I read every single one. Okay, let's go back to the beginning. Every human who has ever lived, every civilization, every poet, every sailor navigating by moonlight, every child who ever pointed up at the sky, they all saw the exact same face. The same craters, the same dark patches, the same patterns. For thousands of years, nobody questioned it. The moon faces us. That's just how it is. But here's what nobody thought to ask. Why? The moon isn't nailed in place. It rotates. It's just that it rotates at almost exactly the same speed that it orbits Earth, once every 27 days. So one side always faces us, and one side is always hidden. Scientists call this tidal locking. Earth's gravity gradually slowed the moon's spin over millions of years until the two fell into perfect sync. So the far side isn't dark. It gets just as much sunlight as the side we see. It's not mysterious because it's in shadow. It's mysterious because we can't see it at all. No telescope on Earth can ever see it. No naked eye. Nothing. For the entire span of human history, it was completely invisible to us. Then, in 1959, the Soviet probe Luna 3 swung around the back and sent home the first photographs. Scientists genuinely did not know what to expect. Maybe more craters? Maybe something roughly similar to the near side? What they got instead stopped them cold. The far side looked almost nothing like the moon they knew. Where the near side has those wide, smooth, dark volcanic plains, the ones that form the patterns we see from Earth, the far side had almost none. Just 1% coverage, compared to 31% on the near side. It was bright, rough, absolutely hammered by craters, no smooth plains, no dark seas, just ancient, battered highlands as far as the eye could see. One side, smooth and dark in patches, the other side, completely different. Same moon, two completely different worlds. The question that has haunted lunar science ever since is simple. Why?
Here's where it gets strange. NASA's Grail mission in 2012 mapped the moon's crust in extraordinary detail, and what it found confirmed the suspicion that had been building for decades. The far side's crust is significantly thicker, about 60 kilometers on average, compared to roughly 40 kilometers on the near side. 20 kilometers of extra rock sitting on one side of the moon and not the other. That difference is the key to everything. Those dark volcanic plains on the near side, scientists call them Maria, they formed billions of years ago when massive asteroids punched through the crust and allowed molten lava from deep inside the moon to flood the surface. The near side's crust was thin enough to let that happen. Magma broke through, it spread, it cooled into those wide, dark, flat plains we see today. On the far side, the crust was too thick. Asteroids hit just as hard, craters formed just as deep, but the magma couldn't reach the surface. It stayed trapped underneath, so you get enormous craters, but no lava plains, no dark patches, just the raw, ancient crater fields sitting there for 4 billion years. But now you have a bigger question. Why is the far side crust thicker at all? That is the question that leads somewhere extraordinary. Go back 4.5 billion years.
A Mars-sized object collides with the early Earth. The impact is almost incomprehensible in scale. It vaporizes rock. It throws an enormous cloud of debris into space. That debris slowly clumps together under gravity and forms the Moon. At this point, the Moon is extremely close to Earth, not 300,000 kilometers away like it is today, maybe 20,000 kilometers. So close it became tidally locked almost immediately, within months of forming. One face locked permanently toward Earth, one face locked permanently away. Now here is the piece that changes everything. The early Earth at this point was not a solid planet. It was a ball of molten rock, glowing with leftover heat from the collision. Its surface temperature was above 2,500 degrees. It was radiating that heat outward into space. And the near side of the Moon, the side facing Earth, was being bathed in that heat constantly. The near side's crust stayed molten longer. It stayed too hot to solidify quickly. The far side, facing cold, empty space, cooled fast. And as the far side cooled, elements like aluminum and calcium condensed first and combined to form a mineral that floated up to the surface and built up layer after layer of thick crust. The near side was too hot for this process to work, so its crust stayed thinner. The Moon has two completely different faces because of which direction it was pointing when it was born. Earth literally cooked one side and left the other to solidify alone in the dark.
Here's the part I promised you at the beginning, the part that genuinely unsettles people when they hear it for the first time. Scientists have been studying the South Pole Aitken Basin on the far side. It is one of the largest confirmed impact structures in the entire solar system. 1,600 kilometers across, 8 kilometers deep in places. The asteroid that created it hit so hard with so much force that it may have punched completely through the crust and pulled up rock from the Moon's mantle, material from deep inside the Moon that has never been exposed to space before. And here is the thing that doesn't add up. In a basin that large, with a crust that thin at that location, you would expect significant volcanic activity. The math says the impact should have triggered enormous lava flooding, the same process that created the dark plains on the near side. There is almost no volcanic flooding there, 3 to 4%, in the largest impact basin we know of in the inner solar system. Which means crustal thickness alone doesn't fully explain the difference between the two sides. Something else is driving the volcanic history of the near side, something concentrated there and not on the far side. Scientists believe it's a cluster of heat-producing radioactive elements, thorium and uranium, locked into the near side's geology since the Moon's formation. The near side isn't just thinner, it's radioactively warmer. It has been this entire time. It's been slowly heating itself from the inside for billions of years. Nobody fully understands why those elements ended up concentrated on one side. It may connect back to that original asymmetry. It may be its own separate mystery entirely. What we do know is this. In April of this year, for the first time in over 50 years, humans flew around the Moon. The Artemis II crew swung within about 4,000 miles of the surface, and when astronaut Christina Koch looked out the window at the far side, she said something felt wrong before she could explain it. The dark patches weren't where they were supposed to be. She was seeing, in real time, what Luna 3 saw in 1959, a moon that looks nothing like the moon we know. For 40 minutes behind the lunar surface, that crew had no contact with Earth, no signal, no communication, completely alone, farther from any other human being than anyone in history. And the world they were looking at out that window was shaped by events so ancient and so extreme that the rock down there still carries the memory of it. A collision that made the Earth, a moon that locked into place before it had finished cooling. One side baked by a newborn planet, one side frozen facing the dark. Two faces, one moon, and we are only just beginning to understand what the Hidden One is trying to tell us. If this is the kind of thing you think about at 2 in the morning, subscribe.
There's a lot more where that came from.